this computer. All right, I can see it's recording. And so I just want to make a couple quick comments, then we'll get right to the polling. I have, we're going to break up into groups again, 8 groups. I have 2 problems for each group. I'm going to try to give you enough time to talk them through and work them. We'll come back and we'll have groups declare their answers so that you know what you're working towards. And then at the end, you will turn in your group's problems. That's what you'll upload to Canvas. And on the subject of Canvas, I haven't created this assignment, so you can't upload it yet. And I apologize to some of you. I didn't create the assignment for Lab 2 until yesterday. Oh, it was late in the day. It may have been around after dinner even. I finally got around to creating because one of you had said, hey, I can't find how to upload this to Canvas. And that's my bad. I just didn't make the assignment. It is there now. Okay, so if you're wondering how to upload your Canvas, just do it sometime today, upload your files. If that's a problem, let me know you need more time. I think I made it midnight tonight, but if you need more time to finish it up and get it uploaded, no problem on that, okay? You probably, and same thing for this assignment, I'll get it created right here after class so you can upload your worksheet, all right? So that's my, my kind of administrative announcements. My apologies for that, and we'll move on. Let's see. Projectile motion, it's harder, isn't it? I mean, some of you may say, I've done this before. You had a great high school or previous college, you took a physics course. It's pretty standard that projectile motion is going to be a topic you're going to have to use. But I think on the philosophy side, the reason it's hard is it could bring to bear potentially most every skill that you need in a physics class. The problem I did, you had to get vector components, right, of the initial velocity. Even the one that you did, the ones that you did last night, your single problem, you had to look at the velocity vector and determine the components. Now, the good news is you could do it by inspection, as we say. You saw that your velocity was horizontal in both problems. And so that means you only had an X component and you didn't have a Y component to the velocity at the start, the initial parameter, the one that's subscripted with an I, and you didn't have to do math to get that, but it is potentially a problem that I can give you an initial velocity up at some angle, and you'll have to figure out what the 2 components are. It's always nicer when it's always horizontal, because then you can just say, I only have an X component, right? But then you basically have to do free fall, so you need to use the constant acceleration equations for free fall in the Y direction, and the constant velocity equations in the X direction, which is everything we've done up to date. The projectile motion problem is one that physics teachers everywhere favor because it is comprehensive in bringing all your skills together. And so for those of you, and there's a number who are able to do that problem, you've come a long way, obviously, in your physics life, either in this class or in some other class, because if you can do that problem, you're staying up and you're right with the skills you need to continue to be successful in the course. If the projectile motion problem is difficult for you, then there's probably some building block skill that you need to work on. Maybe it's getting vector components or even recognizing vector components. Maybe it's the free fall acceleration or the constant acceleration set of 3 equations that you don't have firmly in your mind, or the constant velocity equation, singular, you may not have that. I will say this on a practical side, if you're not considering a projectile motion problem as a good problem on the first midterm, which is what, in about 2 weeks, maybe just a little over 2 weeks, then you're maybe in a little bit of denial, because I can tell you in the years I've been teaching this course, there's always been a projectile motion problem on the first exam. And so that's kind of information, I guess, that everybody likes, news you can use. The only question is, will it have an angle that you have to calculate the initial components? Will it be a horizontal initial velocity? But you'll be doing the projectile motion problem. You have to recognize the parabolic path and all that. All right. So I think that's a milestone, and you don't have to have it fixed today. If you're still a little hazy about it, there's time, because that exam isn't for a couple of weeks. There is a homework where you're going to have to do projectile motion problems coming up. So you should be looking for that. But today's material, I think, is a little bit more straightforward, the circular motion stuff. And let me start sharing so you don't have to look at my ugly mug anymore, my PowerPoint. And it's not often that I can look at one slide and say, if you've got even partial of what's on this slide, you got it all, right? If you watch my videos or the videos in mastering, you found out that the acceleration in this case of circular motion doesn't change the magnitude of the velocity vector, it changes the direction of the velocity vector. And in a more complicated course, we can change both, but in an introductory physics course, we just stay with, let's work on changing the direction of the velocity vector. And anytime you change the velocity vector in any way, it's called an acceleration, right? Changing the velocity vector over time. And we went through the nice derivations of this equation, but at the end of the day, you got to be aware that this acceleration that results when you change the direction of the velocity vector is called a centripetal acceleration. It's v squared, the speed squared, divided by the radius of the circle that thing's moving in. And then you got to be able to find these velocities of these objects that are moving around in circles. And it's such a common thing that happens in our world that it does make some sense that we're studying it. Boy, the lighting in this room is pretty terrible. I apologize for that. But like I said, I'm in the business room at the Holiday Inn Express. So anyway, the distance something travels at uniform speed for circular motion would, of course, be the circumference. And the time that it takes to go around one circle, we call the period. And so if you got the most rudimentary idea in physics that a displacement, a distance traveled, I should say, divided by a time interval, which we call a period, is a velocity, you're good to go on this. By the way, I should say, once something goes around in circular motion, it comes back to what it started with. It is an oddity of the definitions in physics that the displacement then is zero, right? Okay, so we do really want to think about distance traveled here, and we want to think about the speed as opposed to the velocity vector, because something net velocity, kind of an average velocity going in circular motion is really zero, because its net displacement is zero. But that's not what we're going to be talking about, okay? We want to get the speed, circumference over period, and then the centripetal acceleration equations. And of course, we defined a term that was called frequency, which is the reciprocal of the period. If the period is the time it takes to go through one cycle, then I guess the frequency would be the rate at which it goes through a cycle. Okay, so it's the reciprocal of that. And those are the definitions you have to know. All right, where's my polling? There's my polling. There's my first question for the day, launching it. And if you watch my video, you saw a cat doing some motion at the start, launching the poll here. What was the cat doing? It's cute little, it was actually a kitten, wasn't it? Cute little kitten. All right, good. And yeah, as you're probably figuring out from this question, if you saw the video, if you watched it, when you do a distance learning class, and when you teach any kind of class, you always wonder, are students actually looking at the stuff you're preparing, or is it just a waste of time? Are you just making stuff that nobody's looking at? So making assignments, making videos. And so this is, of course, one of my attempts to ferret that out. And if you watched my video last night, this is a trivial question. It's actually a cute little thing that I stole from Dr. Kaiser, one of the other professors in the department, and that's it. All right, so go ahead.
People are writing in the chat to you.
Okay, thanks. Yeah, I'm playing with one screen here as opposed to my normal.
I figured.
Yeah.
I was the one.
Okay, that's a good question. The question is where. Oh yeah, all right. You're right. It's just go with A, B, and C. It's not the correct question. Where to find the videos is an interesting question. Okay, they are in the reading quiz. Okay, and of course the reading quiz sometimes takes you right to some mastering videos.
I only found.
What's that? Mine will always be in the assignment section of that. Okay, and of course they're in files as well, or in Studio is the latest video if you want to go that direction as well. All right, so I apologize. A, B, and C don't correspond here to the question that's in there, but that's all right. I guess we'll live with that. I'll catch up to the right one. Looks like we've got 4 people that aren't going to commit, so I'm going to end. And of course, the answer is that C is the right answer. The cat was going around in a little circle. And for those of you that missed it, go back and watch it. Go back and watch some of these. And I'll just show you this guy right here. I think if I go,
So is the video in Canvas?
the video is in Canvas. It will be found in the assignment, the reading quiz assignment in Canvas. So yes, that's where you'll find this thing. And you can see the little kitten hairs going around in circular motion. And so we'll stop sharing that. And I'll move on, actually stop sharing the poll, and I'll go on to my next question, which should be that one. All right, and I gotta move on to the,
Dr. Tukolsky,
yeah.
could you please just double check that it is in the assignment? Because last night when I was on it, it didn't. Usually we'll have like the video that you
Yeah.
have and then
Yeah,
mastering,
It
but
wasn't
it
there
was
yesterday? All right, I'll check again, okay? Either some people were good guessers or somebody saw it. It will always be in studio though, because there's no way to get it into the assignment if I don't upload it into the studio. So I'll look again. If you didn't see it, go watch it. It's a fairly short video and worth your time. Again, also there were the videos in mastering that were part of the pre-class quiz. And so that's always there as well. But yeah, I'll take a look. Thanks. If there was an issue, I'll apologize and we'll move on. All right, here's the next one. Move on to the next guy here. And this is dealing with that relative motion stuff. And I was just at BWI yesterday. And I'm hoping this relative motion part makes a little bit of sense. You almost just intuit the answer, I hope. And I'm going to, oops, sorry, I gotta go backwards now. There. I like that screen better. All right, we got 23 people in, almost there. All right, 27, I'm gonna call it quits here. And hopefully it makes sense to you that the speed that would be seen by that person is the sum of the speed of the moving walkway, 1 meter per second, and the speed of the person walking on the walkway, okay? Assuming that that person, which I said, is walking in the direction that the moving walkway is going, okay? And that's the whole idea of relative motion, right? That's the deal. And so good for the 17 of you that you'd intuit it that way, and maybe you did the reading. If you saw my video, we talked about this, and so that's a good thing. All right, let's go on to the next one. Similar idea, just working it backwards. So if you got that question, this one hopefully is the same idea, just we're giving you the final speed and we're saying, okay, how fast was the person walking, basically. So work the middle part of the problem. I didn't move on, did I? Sorry about that. Hang on, you're answering the wrong question. I want the bird. I need the seabird here. Okay, so the measured speed over the ground is 35 meters per second, but the bird was flying with the wind at the wind was going 23 meters per second. How fast was the bird going through the wind, through the air? It was there. All right, looks like everybody's in now, so I'll call it a day. Hey, I just checked Canvas and you are correct. It got deleted somehow. I've seen that happen once before to an assignment, but we'll double check it again. I'll post it up as a document by itself so you can watch it. And I guess the good news is it'll be all right after class as well as before, because there's really only two problems you got to learn to do. All right, it looks like we're split here a little bit. All right, and I think I'll share the results. It appears to me that some people added the 23 and the 35, okay, and other people subtracted, which gives you 58, and other people subtracted the two, which gave you 12, okay? And let's just, since apparently the fact that the video wasn't up, I'll go back a step here, and we'll talk about, where is that? There it is. Nope, next one and next one. Yeah, what we say in this, I gotta move this right here, at the very top of my screen here, the velocity of somebody relative to something else is the velocity of something relative to a third thing plus the velocity of the third thing relative to the first thing, I guess. And the key here is, see the two A's in the middle? So this is the velocity of the runner relative to, in this picture, Amy. And this is the velocity of Amy relative to Carlos. And when you add those two, you get the velocity of the runner relative to Carlos. And Amy, by virtue of her little subscripts there being out of the picture, she goes away. So that's the formal way that you work this problem. So in our case, the velocity of the albatross relative to the ground, that was the 35 meters per second, okay? The velocity of the air relative to the ground was the 23 meters per second. And what we were looking for was this little thing in the middle here. And the way you would get that, of course, is to subtract the two. And so that's why the people who chose the 12 meters per second got it right. Now let's think about my first problem, where the velocity of the walker relative to the moving walkway was 1.5 meters per second. And then the velocity of the moving walkway relative to the BWI building was 1 meter per second. You added those two and you got the 2.5 meters per second. And so these two problems are a little different based on what information you're given, okay? Where in the first one, you were given exactly what this equation tells you: the velocity of the walker relative to the moving walkway, the velocity of the moving walkway relative to the BWI building, and the moving walkway step in the middle goes away, and then you're able to get the velocity of the person relative to the BWI stationary building. In the albatross case, we've given you the speed of the albatross relative to the ground and the speed of the air relative to the ground. We're asking you to find that thing in the middle. One more of these, I think, and then we'll put that away and we'll go work some problems. I can stop sharing, and then we'll go on to the next one and launch the poll and advance the slide. And the point of this relative motion stuff, I guess, is that it can work in two dimensions as well, okay? And you do the same thing. In this case, the velocity of the boat relative to the shore is the velocity of the boat relative to the water, and the velocity of the water relative to the shore, okay? Same, I haven't even asked the question yet. How can anybody be answering? So let's go on to the question, all right? And here's the question. Reset yourself. You need me to redo it?
The answer showing.
Oh, I hate.
You have to go one slide up.
Oh, you're right. I went too far. All right. That takes all the fun out of it. But hopefully this makes sense to you. And the answer is, of course, 5 meters per second, because I let the cat out of the bag. I guess maybe the bigger question is, why is it 5 meters per second? And here I'm gonna draw on this guy, since we know the answer now. This guy right here is moving down at 3 meters per second. Okay, once he gets on the conveyor belt, so his net motion, this mouse is that way, and 3 meters per second squared plus 4 meters per second squared is 25 meters squared per second squared. This side right here, of course, is the 5 meters per second. And so I messed up the poll question there, but 20 of you are in anyway. And I guess the bigger reason is why this is the right answer, and hopefully just vector addition and Pythagoras' theorem gives you the answer. All right. All right, let's move on then. And here's the problems that you're doing. I'll share those results with you, but of course, I gave you the answers, so it took the fun out of it. Let me stop sharing that and instead share with you, and I'm going to start the breakout rooms here. At least create them while I'm sharing this screen with you. There it is. There's share that. And I need to do this, screen mirroring. Come on, you can do it. Of course it's not. Why would it work? Let's open up Word and go right to that. Stop sharing that because it won't screen mirror, and instead we'll share the Word document, which I know I opened. It's right there. All right, screen share. There it is. All right, so I have 4 problems, and hopefully you're seeing the first one. And this is a circular motion problem where you have to draw it, figure out the centripetal acceleration, and express the magnitude of that acceleration in G's, which was a question I think came up in one of the, either a reading quiz or a homework. Number of G's, just take your acceleration and divide through by 9.8 meters per second squared. You hear that people use that expression, and that's all they mean. If you have a number of G's, just multiply by 9.8 meters per second squared, and that'll give you what the actual acceleration is. So that's what we're asking you to find here. Here's another circular motion problem, and it's just a penny going around on a turntable, and you're trying to find the centripetal acceleration again, and this time period, okay? And then 2 relative motion problems. One is a boat moving on a river, and another is a boat moving through the Atlantic Ocean trying to get into Fort Lauderdale. Okay, and this one's a 2-dimensional problem like our little mouse on the conveyor belt. And you'll notice 2 of them are numbered 1 and 2 of them are numbered 2. And so here's what we're going to do when we go into the breakout groups. All right, here, okay, so in room 1, we got Aiden, Ellen, Katie, and Sydney. You're in room 1. Shenyi, Elena, Maddie, and Nina, you're in group 2. Group 3 is Anna, Olivia, Shanice, and I'm going to get it right. Yaya Wang, Mr. You're in group 3, and then 4 is Kristen, Emma, Sam, and Tommy. Okay, you guys are doing the problem 1s in your respective groups, and then in groups 5, 6, 7, and 8, well, that's everybody else. If I didn't call your name, 5 is Allison, Andrea, Abarici. 6 is Cora, Michael, and Rachel. 7 is Jackie, Kyle, and Stephanie, and 8 is Jael, Megan, and Sean. You guys are doing the 2 problem 2s. Okay, and so I'm going to put you out, and we'll be back probably in about 15 minutes or so to talk about answers. Go ahead. All right, I still see Sam and Maddie. You're not making it.
Yeah, I got kicked out.
Okay, let me try to see. You guys were like, yeah, you're in your. Let me move
today. I think I'm having trouble because it keeps kicking me out of the meeting.
Okay, so let me see if okay, it says you're not joined right now. Let me see if I can move you to breakout room. Let's try a different room. I'll put you in one of the 3-person rooms. You can go to, we'll see if we can send you to 4. And Sam, where are you?
I was in 4.
We're in 4.
Yeah.
Let me see if I can get you to. Somebody has a rooster crowing in the background there. Maddie, you're back.
Sorry, it's like giving me troubles with the
Yeah,
breakout
all right.
room.
No problem.
I'll try again.
Yeah. Where did it leave you though? Move you to. Try to move you to 7 this time. And move you to 8. Sam, you're still here?
Yeah, it's not letting me.
All right.
Oh, hold on. I think it popped up.
All right.
Yeah, it kicked me out again.
All right, now I got to figure out where it puts you, probably at the top. Nope, you're not at the top. There you are. Let's try group 6 then. All right, if it doesn't let you go, nope, you're gone now. Look at that. All right. All right, it's quiet in here. Have you figured out what the period is yet? Anybody have a number they want to throw out?
I was having trouble on that one, so I went to the second one.
Okay, well, I think the issue is you need it in seconds, right?
Or is this the hammer one?
No,
where
you
it's
guys
on
are
the
doing 2,
symbol?
aren't you? You could do the hammer one, but I thought your group, I thought group 8 was doing problem 2, the number 2 problems.
Yeah, number 2, it has a hammer and then a penny on it or something.
Well, that's not what I thought, but let's take a quick look here. And let's go see what's in, where'd you pull the document up from Canvas?
Yeah, from files.
All right, let me go there and see what you got. And it is, okay. That's the cute cat. 3. Yeah, I'm looking at problem 2 and I'm seeing a stereo turntable turns at 33 1/3 revolutions per minute. What's the period for 1 revolution?
Oh, it say create a drawing that shows a hammer?
Yep. Oh, it says hammer. That should say penny. Yeah, sorry about that. That's a typo. Yeah. So create a drawing that shows the penny at an instant in the circle. That's a typo right there. That's from the first problem.
Okay.
So I think we agreed though 33 1/3 revolutions per minute, right?
Yeah.
Okay, so what you have to do is you have to change that to revolutions per second.
Okay.
And so 60 minutes in a second, so you're dividing through by 60. And then to get the time it takes, you want the seconds per revolution, which is the reciprocal of that. So first convert revolutions per minute to revolutions per second, and then take the reciprocal.
Wait, take the reciprocal of what?
Okay, so you get of 33 revolutions per minute converted to revolutions per second.
Wouldn't it just be times 60?
Well, if you're going per minute and you got to get to per second, you divide by 60, right?
Oh. Oh wait, it's 33 1/3.
Yeah, 33 divided by 6, it's roughly a half, right? It's a little over a half of a revolution per second. And then to get the time it takes to go around in 1 cycle, you take the reciprocal of that. And so it should be just a little less than 2 seconds. Then once you got that, then you should be able to get the velocity from circumference over period and the acceleration, the velocity squared divided by the radius.
Wait, I still don't understand the reciprocal part.
Okay, what are the units on that 33 revolutions per minute? Do you have that step done yet?
Isn't it
What number do you get and what units do you get?
0.55?
Good, that's your number of revolutions per second.
Okay.
And then to get the period, you take the reciprocal of that, because then you'd want seconds per every revolution. And so take the reciprocal of 0.55 revolutions per second, and you get something like 1.8 or something like that.
Oh,
That's the period.
how do you take the reciprocal of like a decimal?
You just every calculator is different. Some have a 1/x key. Others you can raise it to the -1 power.
Oh, okay.
One of those 2 steps.
So is it 1.8
Yeah.
for the period?
Yep.
Oh,
Exactly.
okay.
All right. And then the velocity, you just take the circumference, 2 times pi times the radius. In this case, the radius, I guess, is 10 centimeters. And then you divide it by your period.
Okay.
All right. Got the rest. And then acceleration is that speed you get there squared divided by r. I'm going to go to another group.
Okay.
Hey, one quick typo on this one.
We were
You
supposed
guys
to
are
do
doing
the
problem.
yacht problem.
What's that? On problem 2, where it says create a nice diagram that shows the hammer, it should say shows the penny that we're talking about. Okay.
We did the other number 2 by accident.
Okay, so you did the second one first?
Yeah.
Okay,
The
that's fine.
relative-
You're gonna have to do both. What'd you get for an answer?
We got 18.43 for the angle.
Yep,
And
looks
then
good.
11.3 KTS for the.
Knots, yeah. Okay. How'd you get the 11? I didn't quite get that 11 because it's 12 knots.
Then?
What's that?
What'd you get? Did you get like a 12 point?
I got 12.6 because you
Yeah,
squared the 12, right?
Yeah.
And you squared the 4. So it's 144 and 16. And then you added those two together and took the square root. It's got to be greater than 12.
Yeah, I accidentally subtracted them.
There you go.
But yeah,
So about 12.6. Everybody else good with that? Rachel, Cora, you guys all right?
Yeah, sorry. I thought I was unmuted.
Yeah, that's fine. Then go back to the other number 2 then on the first page, because you have to do both. And where it says a stereo turntable, create a nice drawing that shows the hammer. It should say the penny, which is sitting on the turntable. That's what's referenced in that problem. So change the word hammer to penny. And then you get the period from that 33 1/3 revolutions per minute. So the first step is you got to turn that revolutions per minute to what we normally use per second. So you got to convert per minute to per second. And that actually is a frequency, what we called F in the reading. And then you got to take the reciprocal of that to get the period. So basically 1/33 1/3 revolutions per minute would be the number of minutes per revolution, and you got to convert that to seconds. And once you got that, the velocity is 2 times the circumference, 2 times pi times r over the period. And then the acceleration is the velocity squared, the speed squared over the radius. All right, so those are the big equations, I guess. And I'm going to jump out while you guys work on that one. All right, I'm on, where did group 6 go? There they are. There you are. So I'm going to join 5 then. All right. Hey, you guys are doing problem 2 where there's a stereo turntable.
Yeah.
The one thing that I wrote here, putting a hammer on a stereo turntable would probably break it, because then I change it to a penny. It's meant to be a penny. And so I apologize for the word hammer there. Okay. So, but you still have to get that frequency that's in revolutions per minute. You want to turn it to revolutions per second. And then you want to take the reciprocal in order to get the period. Did you guys get to that step yet, or are you still working on it?
Elson helped.
Oh, we did it. Elson helped me.
Okay, what do you got for a number? Let's check your answers here.
I got the
Go for it.
frequency is 0.556,
Right, that's revolutions per second. And then what'd you get for a period?
1.8.
Perfect, okay. And again, I apologize for saying hammer in the problem. That added confusion. What'd you get for your velocity then?
0.35,
Yep, looks good. And how about your acceleration?
1.22.
Perfect. All right, you guys got it. Did Allison and Andre, you good with those answers?
Yeah, I'm
Yeah.
good.
Okay, cool. All right, so then you did the yacht problem, or are you still working on that?
Yeah, we did it.
What's that?
I think we did it. Yeah.
Okay, so
did
what'd you get for the angle and the speed then?
For the speed, I got 12.6.
Looks good. So you just squared the 12, squared the 4, used Pythagoras' theorem to get the that magnitude. Okay, good. And what about the angle?
Mm, 18 degrees.
I got 18 and a half, but you took the
Okay.
arctangent of 4/12, right? And that got
Yeah.
you.
All
All
right.
right.
Time.
You guys all good with that then? Perfect. Perfect. All right, I'm going to leave you guys. We'll be finishing up here. You can just kind of take a little break, and we'll be finishing up in about, what time is it? Just a couple minutes. Probably in about a minute or two. All right.
Okay.
Going to the next group. All right, it looks like I am in group 4 here. How you guys doing? Have you finished the hammer thrower problem?
Yeah, we're
We
on
finished that one.
Okay.
part A and B of 2. Well,
So you're almost done. You're on 2B. Okay.
second one. Whatever.
Now, what'd you get for part A?
30 kilometers per hour.
Yeah, it's always that, isn't it? Okay. Are they moving in the same direction or the opposite direction?
Opposite.
Okay. And so we're given the velocity of the boat relative to the water is 25 kilometers per hour. And then they're going upstream. So the water's going in the other direction. And so what I think you do is you add those two, but one of them's negative because it's in the opposite direction. Does that make sense? Yeah, you added them as if the river is taking them. They're 25 kilometers per hour, and the river is also moving at 25 kilometers per hour in the same direction, in which case it would be 30, right? But they're going opposite, and so you've got a positive 25 added to a negative 5 kilometers per hour. And so I think the net is that they subtract. You're adding two things in the opposite direction now.
Okay.
Does
Yeah.
that make sense?
I
Yeah.
think we subtracted.
Oh, so you subtracted
So
the 5?
yeah, we subtracted the 5,
Okay.
which would
Yeah.
add it because it's negative.
And it may be the words were, upstream, downstream, all that, but that is hopefully the point. And so once you believe that, then you won't be able to get the second part right, because you got to start with that 20 kilometers per hour, right? And if you started with 30, then you're gonna get the problem wrong, even though it'll be kind of error carried forward here. So what are you going to do with the 3 kilometers per hour that the person's walking from the bow to the stern? Are you going to add that or subtract that from part A? Boat's going that way, right? And the person is walking this way, okay? Is that person's speed going to be more or less than the 20?
Less.
Yeah, it's going to be less. So you'll subtract that off. And that's kind of how you can think about it. The equations are nice, but it has to sort of make sense that that person will be doing the 3 kilometers per hour less. All right, I'm going to leave you guys alone and go on to the next group then. That we're probably going to have to end here in a second. All right, you guys done? Did you guys get the first one, the hammer throw problem? Are you on the relative motion problem? Which one are you working?
We got the first one on the first page.
Okay.
But we're supposed to do the first one on the second page as well, right?
Also, yes. And it's pretty quick. What'd you get for your acceleration for that first one? How many meters per second squared, or how many G's? You can give me either answer. What'd you get?
For acceleration, we got 273.
273, perfect. And then you just divide by 9.8. When people talk about the number of G's, it's about 27.8. And that's just how people talk. So it's not really a physics question. It's more how do people communicate. All right, let's talk about this boat problem. So the boat's going that way at 25 kilometers per hour, and the river is pushing back at 5 kilometers per hour, okay? So it's the velocity of the boat relative to the water is 25. The velocity of the water relative to the ground, I guess, because that's what the river current is going in the opposite direction at 5. And so you're adding those two things. What do you think you're going to get? And it's kind of, you have to decide you're either taking 25 plus 5 kilometers per hour, or you're taking 25 minus 5 kilometers per hour to get the speed of the boat with respect to the ground, with respect to the shore, if you like. What do you guys think?
Would it be 20
Yeah, it'd be 20.
kilometers per hour?
Yeah, and hopefully that makes some sense. I mean, you kind of go, yeah, that's going that way. If you ever tried to take a boat upriver or against the current, you know, if you're paddling or what, you got to work real hard because the current keeps pushing you back. So absolutely 20. And then just do exactly the same thing now. Once you got the 20, now you got a person, I guess a child, walking from the bow, the front of the boat to the back. Is that person doing more than 20 kilometers per hour or less? And I'll let you think about that. I got to go in the meetings. All right, but think about it exactly the same way. You saw the first one, so I think you'll get the second one too. I'm going to leave.
Okay, thank you.
You bet. How do I jump out of this? I hate files. All right, well, everybody's coming back. I want to show you something that I think I confirmed that you said. And hopefully you're seeing my Canvas screen, which I'm thinking looks like your Canvas screen in the module mode. Of course, I've never seen it from the student view. And I want to show you the reading quiz that was Mondays. And so this is what I'd hoped it looked like. Okay, direction to say read this chapter, which is right out of the schedule on the syllabus. Then watch this video, okay, which was Monday's video. And then, of course, do the reading quiz in mastering right here. Okay, so that was Monday's assignment. And that one looks exactly like I created it, so I was happy with that. But, and don't ask me why, go to the modules again for Wednesday's class. And that was reading quiz 3-2. And see where it says college physics 1 right there? There was supposed to be a video tucked right in there like there was for 3-1. And I can see that it's not there anymore. And the same thing for today's. So I can see the last 2 Canvas dropped my video, which means I was stressing Canvas too much, trying to make it do something it didn't want to do, because there's 3-3. And again, you can only see the mastering video that hopefully you watched, okay? And so you missed the relative motion part. So here's what I'm gonna do from now on, since this happens apparently in Canvas sporadically on me. I'm gonna create, there'll be 2 assignments then for Monday, okay? You'll see my video as a separate assignment from the reading quiz. I was trying to merge them together, and that apparently is more than Canvas can handle. What I will do, because I still think you should watch them, is I'll post them up right away on Canvas separately. They're in the studio, like I said, but there was a video that I created for both Wednesday and today. And if you missed it, well, we've done the problems now, I guess, so that's good. Hopefully those two videos will make some sense for you. And you know, that's the way we'll do it. Yeah,
I
go
don't
ahead.
think we have the studio. I
So
can't find the studio on my own.
You don't have studio?
No.
Okay. I didn't realize students don't get to see that. Okay, then that's why I have to create an assignment, and it'll jump you into the studio that way, okay? All right, so I'll create those assignments right today after class, and you should be able to see them for Monday. And I've got Mondays, all I have to do is click on it. Monday's reading assignment, reading quiz, and video is also ready to go, prepared the old way. I'm gonna split that out. So look for 2 things, the assignment to watch the video, and then the reading quiz before class, okay? And I'll post the 2 that we've missed, today's and Wednesday's as well. Okay, I think that's about our end of our time here today. The one thing you do have to upload into Canvas, and again, the assignment should be ready. The 2 problems that you did in class today in your breakout groups, write your solutions on a piece of paper and upload them, just your two. So that if you're in the first 4 groups, it was problem 1 on the first page, problem 1 on the second page. And if you're on groups 5, 6, 7, 8, it was problem 2 on the first page and problem 2 on the second page. And you could fix that typo from hammer to penny, or change it both from penny to hammer, just make it consistent, either one. But the stereo turntable problem, I don't know why I called it both a penny and a hammer. I meant it to be a penny, but you could just as easily put a hammer on the turntable as well. All right, any questions on what you're uploading? And again, you'll have some more videos to watch. Just get it done in the next couple days or so, sometime next week even. If you've been doing the problems, hopefully watching those videos will make more sense. Hey, you guys have a great weekend, and we'll see you Monday morning.
Okay, I have a question.
Sure,
Oh,
go ahead.
no, you go first. It's fine. It's fine.
I just had a question regarding mastering. I was just curious about the one answer because it said I got it wrong, and I just want to see where I went wrong.
Okay, let me stop sharing this. Can you share? If I let you share, do you have it opened up right now?
Yes, I do.
All right, let me let you share screen. And okay, authorize. So try to take the share button and share.
I got it.
Go ahead, share it with me.
So it's this question.
Okay. So this is okay. Amy's standing on the ground. Bill is riding his bicycle. Carlos is driving his.
I got the question wrong too, so like, yes.
Okay, so Amy's standing still. Bill's riding his bike 5 meters per second. Carlos 15 meters per second. And Bill is going east. Carlos is going west. Okay, so how fast does Bill see Carlos moving? Okay, how would you go about doing it?
So I was thinking Bill is going 5 meters per second, like
right,
east, and Carlos is going 15 west. Wouldn't it just be 15 minus 5 to get to 10?
Except they're going in opposite directions, isn't it? So it's 5 minus a minus 5.
Would it be?
The answer should be 20, right? And do I get a tool here I can write with? Let's see if I can write with something here. Where's my little? Yeah, okay, I can annotate. I think I can annotate. So what we said is, yeah, it is. I can write. Good. So you got the velocity of Bill relative to the ground, and that's equal to, I'm going to call east positive. So it's 5 meters per second. And you've got the velocity of Carlos relative to the ground, right? And that's
15.
15. Yeah, negative 15 meters per second. And so let's see, you want the velocity of Carlos relative, that's supposed to be C. That's a C right there.
Yeah.
Relative to Bill, right? Now the equation in this case, I guess, would be, and I can do it multiple ways. The velocity of Bill relative to the ground is equal to the velocity of Carlos relative to Bill plus the velocity of Bill relative to the ground. Now, I'm being very formal with this method here, okay? But what we're looking for is that term right there. And notice these two guys are in that middle position. Up, you know what? I've got them backwards here. This will give me the velocity of Carlos relative to the ground. So this isn't going to work. That right there is what's left over. Carlos relative to the ground. How's that?
Yeah.
Okay. So that's, yeah, when I started to write there, I was working in my head backwards. Now we know these positions. This is the minus 15 meters per second. And this is Carlos relative to Bill. So I guess that's what we're going to find. And then this is, and it's going to turn out negative from the way I've set this up. Yeah. And that's that, right? And so I'm going to find right here that the velocity of Carlos relative to Bill is minus 20.
Okay.
And that's now, so, but the question doesn't ask for that. I've found an answer, but it's not the one it's asked. It's asking for what is the speed of Carlos relative to Bill. So it's asking for this, right? And that would be plus 20 then, right?
Well, I think minus 20 would make sense because the only option is 20 westward, and we said that westward's negative.
Yeah, and that's only because I flipped, is it Carlos relative to Bill or Bill relative to Carlos? It's the same magnitude, just opposite direction. So that's what makes it 20. The fact is, though, you're adding the two magnitudes up. And that's, and I kind of worked it backwards, but, you know, just coming into problem cold, that might be what I would have gotten. And you would have seen 20 is the one to go with. All right.
Yeah.
Does that help? Okay. Yeah. But kind of think about, they're going away from each other. Okay. So it's, yeah, it makes it, you have to add the two, and that hopefully it makes sense as they're.
Yeah. It makes more sense now.
All right. Sounds good. Who's next?
Thank you.
You bet.
I have a question.
Okay, go ahead.
For number 2 on the first page, is it 0.03 seconds for 1?
Number 2 on the first page. Let me pull that up. Let me pull up something I can write on here. Whiteboard. All right. Hopefully you can see my whiteboard right now.
Yeah.
Okay, and this is number 2 on the first page, right? So we've got this frequency of 33 and a third, I guess, so 0.3. It's a repeating 3, but I'm going to cut it off right there. And it's revolutions per minute. By starting out the way you want?
Yeah.
Okay. The first thing you got to do with this is convert it to revolutions per second, because we don't like the units a minute. I mean, you want to, all our accelerations, all our velocities have been meters per second, so I got to get rid of the per minute. And so what I know is that 1 minute is the same as 60 seconds, right? Okay, and so that minute right there cancels that minute right there. And when I divide a little over 30 divided by 60, I get just a little over a half, 0.55. And that's revolutions per second, okay? Well, if I want to get the time then to go through 1 revolution, the reciprocal of that would be seconds per revolution. How many seconds does it take to make 1 full revolution around? We call that a period. Okay, so it's 1 over 0.55 revolutions per second, and that's a big long divisions. So I take the reciprocal of that, I got about 1.8. Okay, and so that's seconds. That's how many seconds it takes to go through 1 revolution. Most people drop the per revolution there and just say, well, the period is then 1.8 seconds. So does that answer your question?
Yeah. And
okay.
Then for the second part, you would take that number and do the circumference over the period, right?
Yes, exactly. That gets you the velocity. And then to get the centripetal acceleration, you take the velocity squared divided by the radius. Okay? Yeah, but in order to get the problem right, you got to do that piece, don't you?
Yeah.
Yeah. Okay, good to go now?
Yep, thank you.
Bet. And Eberici, sorry, you were last here.
It's fine. It's fine.
Hopefully those questions were things that you needed to see too, I hope.
Yes. I have a question on the last worksheet, the projection worksheet.
Yeah, okay, go ahead.
On number 3.
Yeah, let me pull that. Hang on 1 second, let me get my copy. All right, good to go?
Yes. Okay, so the number 3, when they say it's launched off horizontally, does that mean it has 0 angle?
Yes, exactly.
Okay, so I'm approaching this question just backwards, like it has the same angles as question 2. It has the same angle as question 2, so 0
Yes, you do.
angle.
Yeah. Ooh, I almost pulled the plug out here. So
So
the picture looks like
okay.
that, right?
Mm-hmm.
And so that's the initial velocity of the thing as it comes off the cliff. And it was in your problem. Do I have that?
So I did both question 2 and question 3.
You only had to do
But-
one, but that's fine.
Yeah, but like I did question 3 for extra practice.
Okay, fine. That's a great idea. All right,
Okay,
so let's see. You do it exactly like you did 2. And what's the number here? You're given this one. You don't know what that velocity is this time,
Yes.
right?
That's what I wanted to ask you. So I did the VF squared minus V equals VI squared plus 2AD because I knew, and the change in velocity because there's only one velocity, right? Which is I got 20.77.
Yeah, hold it though.
But I didn't know like.
I don't think you can do what you were trying to do. Okay, I'm going to write out all the equations here.
Okay.
In the x direction, you know that the initial velocity in the x direction is that thing that I'm calling v right here, right?
Yes.
And that's what we're trying to solve for, I guess, in B, aren't we? Okay. And so let's see, what else do we know? Well, in the x direction, I know that the x final position is equal to the x initial position plus the velocity in the x direction initially, which we don't know because that's what we're trying to find right here, times the time interval. I do know this though, don't I? Isn't that 40?
Yes.
That's the 41.
Mm-hmm.
Okay. I guess I could call that 0. Why not? Right. But I don't know either of those two. I don't know the time interval and I don't know the velocity in the x direction.
Mm-hmm.
That's what we're trying to solve. Okay. That's all I can get out of the x direction. In the y direction, I know that y initial is equal to 22, right? And then the equations I know in the y direction are y final. Oh, I guess I do know what y final is, right? It's going to come to the ground. That's a final.
Ground to 0.
0, yeah. It's a common way to do it. But so then let's see, is equal to y initial plus the initial velocity in the y direction times the time interval. Hold on, one other thing I guess I know. What's the initial velocity in the y direction?
The what? 0.
0. So that term's going to go away, right? And then minus 1/2 g. I'm going to write it out here just to 9.8. I don't know why I'm being inconsistent, but 9.8 meters per second squared times the time interval squared. And let's see, we know what the initial value is. It's 22. That's 0. We know everything in this equation but time, don't we?
Yes.
So that's how you figure out part A. You solve for that time. That's how long it's in the air, right? That's how long it's doing this free fall motion here. Okay, before it finally comes to rest on the ground. All right, so that's part A. Solve for that. And then this, go ahead.
I kind of so what I wanted to do before was the v squared one.
Yeah,
and,
so you wanted to do this. V squared.
And I just did this one.
Yeah, v squared final
FY.
is equal to v squared initial plus twice the acceleration times delta y, right? And
Yes.
I think, let's see, the initial velocity is 0, okay? You can find the y final squared. That's just.
I also got 2.1.
Well, you can do it. It's going to be a little bit of a problem though, because this is minus 9.8 meters per second squared. right? And you're going to have to take the square root of a negative number.
Yeah.
Here's why I think it works. What is the change in y? Well, it's the final position,
That's 22.
or is it
Maybe
minus 22?
minus.
Right?
Yeah,
It's
minus 22.
it's
Yes.
final minus initial, right? That's what we said. So it's
Mm.
0 minus 22, okay, meters. And so it's minus 22. And that's a good thing, right? Because you need
Yes.
these two things to be positive so you can take that square root. Okay, so this will give you the final velocity in the y direction, won't it? So I
Yes,
guess
that's
so
yes.
so for part C, you can use this
Then I
method,
use that in
but you still haven't answered part B, right?
one,
Yeah. So
and I use that to do. Then wait, so I use that because my thinking process was that that was the final velocity. So I use
that's
that
the final velocity
VF
in the
equals
y
VI plus
direction.
AT.
Yeah. So that's part of the answer. What'd you get for your number?
I got 2.11 seconds for the time.
Okay. I agree with that.
But I got 20.77 meters
For
per
the
second
velocity.
for the final y.
Yeah, and that's, you
Yes.
found this right here. 20 point, you said 77. I rounded it to 8.
77.
Yeah, okay. Same thing.
Mhm.
And it's downward, right? So it's really the negative. When you took the square root, you needed to know to
Yes.
take the negative part of that. That's the problem with doing it that way, which is not wrong. It's just,
Okay.
yeah, okay.
Mhm.
By the way, the way that it would absolutely get you, that's the one problem with that equation is when you take the square root, you can remember it could be the plus answer or the negative answer. And in this case, you have to look at it and go, when it finally hits the ground, y is downward, so it's going to be negative. X is still positive, but it still hasn't answered the question, what is the velocity in the x direction, which is part B, I guess, right?
What's the velocity? I took the time
right
that I found, and then I did XF equals
yes
XI
so,
plus VIET. Yeah.
So you use that equation right there.
Yes.
The one I just
did everything like backwards, like backwards.
Yeah, okay,
backwards.
that's fine. But
Yeah.
once you had your time of, what'd you say, 2.12 seconds, you put it right there. We decided that's
2.11, yeah.
And we put 41 there, and then you solve for velocity x initial. And what'd you get? What number did you get?
I got 19.4
Okay.
meters per second.
Again, we rounded slightly different. I got 19.3, but we'll go with your number. Close enough. Okay, so now what's the overall speed? Well, you've got to take...
that Pythagorean.
Yeah, you got to use Pythagoras' theorem here. So the square root of the x component squared plus the square root of the y component squared. So you take this number right here, you square it. You take this number right here, you square it. You add them up, you take the square root. And that's the speed, isn't it?
Yes.
All right,
and
good to go.
I think that was kind of like my question.
What did you get?
I also have another question, but that was kind of like my question. I got
your question was, what did the
28.4.
result of that calculation get you? Because you thought it was total speed, right?
Wrong. Yes.
Yeah, and it's not total speed. That's only the y component of speed because you're only using the y acceleration, right? Yeah, that 20.8 you got is only y. It's only the y speed, not the total speed.
That was my... I was kind of confused.
Yeah,
and it also took me a while to
now?
realize that launch course. Yes.
Does it make sense now? Yeah. Okay.
Yes.
And that's because the x and the y motion are completely separate from each other, aren't they? Yeah, and that's
so whenever you say launch horizontally, sorry, whenever you say launch horizontally, you mean like it has a zero angle. It would just launch straight off, right?
Yes. Yeah. Exactly.
Yeah.
All right.
Okay.
You had another question. What was your other question?
It pertains to lab. So in the lab questions, it says like describe. Let me just read it out it says to describe in words the shape of the two position, time graphs when the objects are in free fall. So does it just say describe that just say like the slope is downward sloping and it's just in a like
Okay. This is
in a
position versus
parabolic
time, right?
time? Does
Okay,
it,
you just gave, the word you
Mhm.
just said, I think is the one I'm looking for. Did you just say parabola?
Yes, I just said parabola.
That's the word I'm looking for. The shape of the curve is a parabola,
Okay.
right? What I got is something that looked,
Mhm.
something that looked like that.
Yeah.
And I want you to say that. I want you to realize that's a parabola. And if you got that, you've described the shape in words. Okay?
Okay. So I'm not going to overcomplicate it. That's kind
Yeah,
of like
just,
what.
it's, here's what it's not. And this is, I guess, what we're trying. It's not a straight line, is it?
Yes.
That's not what it is. And that's all we want you to understand. It's a parabola. And if you got that, met the learning objective, we're good to go. Okay?
Okay.
All right.
Thank you.
You bet. You have a good weekend.
You too, sir.
Bye-bye.